2024 times 2. This is AAHL Paper 3, Question 2. It is, in my opinion, a pretty very stupid question. We have a quadratic, have coefficient ABC, right? But ABC is generated by dice. Alright, so 3 die. So it can only be 1 or 2 or 3 or 4 or 5 or 6. Question: why is there 216 possible quadratic equations? Because A have 6 choice, B have 6 choice, and C have 6 choice. That multiplied to 216. So now let's say A is 1, B is 4, and C is 4. Why does it only have one x-intercept? Well, it's because of b squared minus 4ac. So it's 4 squared minus 4 times 1 times 4 is 0. Therefore, if the discriminant is 0, there's only one x-intercept. So consider the discriminant, show that the probability that the graph of such a quadratic having only one x-intercept is 5 over 216. So this is the beginning of like a tricky part of this question. So in some sense, you hint that you should use the discriminant. So you want b squared minus 4ac to be 0. The second important thing about this question is the fact that all of ABC can only be 1 to 6 integers. Alright, so this turned out to be very important for like the whole question. If you somehow didn't realize that, then you lose a lot of mark. But if you do realize that, then this question is suddenly not hard, because after all, there's only 6 options. So you will see that in this question, all you're doing is you're basically just trying all the possibilities. Alright, so that's what I mean by the question is kind of stupid. It doesn't test a lot of math. Yeah, but I hope you see. So have that in mind. Now remember, there were 216 possible quadratic functions that you can generate in this way. So by telling you that the probability is 5 over 216, is actually telling you there is 5 cases where the discriminant would be 0. So to get the 6 mark, you actually simply have to, just by trial and error, find the 5 cases. Okay? So yeah, that's one way. You just keep trying. But I guess I would try to do a little bit of math to make it a little bit more systematic. So if b squared minus 4ac is 0, then b squared is 4 times a times c. And b could only be 1 or 2 or 3 or 4 or 5 or 6, right? So these are all okay. Now if b is 1, then b squared is also 1. Then there's no way that b squared would equal to 4 times a times c, because the smallest that a and c could be a 1, but 4 times 1 times 1 is already 4. Okay, so that's not possible. Now if b is 2, then b squared is 4. Then now it's possible a is 1 and c is 1. So you pretty much just keep trying this. Okay, if it's 9, I don't think 4 times anything is 9, so that's not possible. Then if b is 4, b squared is 16, then this should be possible. We can have 4 times 4 to give 16, so either a is 4, c is 1, or the other way around. Or they're both 2, right? Yeah, so you see, you're really just counting all the cases. Listing them all out. You know. So 5 squared is 25. I don't think that's a multiple 4. Then 6 squared is 36. That should be possible. I think it's 3 and 3. Alright. Because you need 4 times 9. So how many cases are there? 5, right? 1, 2, 3, 4, 5. So you say there are 5 ways. There are 5 ways. Therefore, the probability is 5 over 216. Alright. So you see, that's the idea of the whole question. Well, at least mostly. Now consider a quadratic that have 2 distinct x-intercepts. So now basically the discriminant have to be bigger than 0. What are the possible values of a times c? So this part is actually quite confusing for a lot of students. So they want 2 distinct x-intercepts. So that's like, well, that means b squared minus 4ac is bigger than 0, right? b squared minus 4ac is bigger than 0. So b squared must be bigger than 4ac. So what are the possible values of a and c? Well, you see, b squared, the biggest that b squared could be, alright, since b, the biggest b could be 6, right? It's 36. So we know AC is really less than 36. That means a times c is really less than 9. Well, but if it's at most 9, then that means AC is at most 8. Then what's less than 8? 7. But here's a trick. If A can only be 1 to 6 integers and C can only be 1 to 6 integers, they can never multiply to 7. So there is actually no 7. But there could be 6, could be 5. 1 times 5 is 5. 4, 3, 2, 1. So turn out that's the answer. Those are all the possible values of A and C. And somehow that's worth 3 marks. Right. Now, consider if AC is 1. What are the 4 quadratics that can have distinct x-intercepts? Okay, now, so if AC is 1, so the first question is, how can AC be 1? Well, A have to be 1 and C have to be 1. And then to have 2 distinct x-intercepts, the discriminant must be bigger than 0, but AC is 1, so b squared simply need to be bigger than 4. For b squared to be bigger than 4, b could be 3 or 4 or 5 or 6. Right, so that's the 4 cases. A have to be 1, C have to be 1, but B have 4 choice. Therefore, there are 4 ways. So those are the 4 quadratic functions. Alright. So now you see how dumb the question is, right? You really just list them all out. And II. What happened if AC is 2? Well, we play the same game. AC is 2. What could A or C be? Could be 2, 1, or 1, 2. But b squared minus 8 has to be bigger than 0, so b squared have to be bigger than 8. How can b to be bigger than 8? Oh, again, b has to be 3, 4, 5, 6. So b have 4 choice, but there are 2 different ways to configure A and C. So there are 4 times 2 ways. So 8 ways. Alright. Now the question is then, what is the probability that the quadratic function generated this way have 2 distinct x-intercepts? And the hint is, do what you were doing in part E. Well, what were we doing in part E? We're trying to list everything out. Alright, so we'll continue. AC was... So we have ran through AC being 1 and 2. We still have 3, 4, 5, 6, and 8 to go through. So now you probably see why this question is super dumb. And if you didn't realize this is the game that they want you to play, then you lose a lot of mark for no reason, right? So AC is now 3 with 12. So B squared needs to be bigger than 12. How can B squared be bigger than 12? Oh, there are 3 ways. So B is 4, 5, or 6. So there are 3 ways. If AC is 4, then could be A is 4, C is 1, A is 2, C is 2, or A is 1, C is 4, but B squared needs to be bigger than 16, so B has to be 5 or 6, so there are 2 times 3 ways, so 6 ways. If AC is, what's the next possibility? 5, A is 5, C is 1, or A is 1, C is 5, and B squared have to be bigger than 4 times size 20, so B could be 5 or 6, or what, 4 ways, because 2 times 2. If it's 6, A is 6, C is 1, A is 1, C is 6. Is there another way? No, right? B squared need to be bigger than 6 times 4 is 24, so B can still be 5, so there are 4 ways. And if AC is 8, I don't know, even if you know this in the exam, you kind of doubt yourself, right? It's like, is this really what IB wants us to do? 32, so B have to be 6, so there's only 2 ways. And then we add up all the possible ways. How many ways are there? Remember, there is more. Yeah, by the way, I marked this paper in the last exam period, so I kind of know the answer. Yeah, I missed this. There is actually 6 ways. We might need even more. Is it here? I also miss A being 2, C being 3, and 3, 2. So there's actually 8 ways. Yeah. So, is it there? 4, 6 plus 6 plus 4 plus 8 plus 2. Oh, that's the right answer. Okay, yeah. But yeah, I miscounted. I'll lose a mark if this is the actual exam. Okay, so at the end, they figured they ran out of stuff to ask about the throwing dice. So they changed the idea a little bit. Now, instead of a dice, we're generating the coefficient by using a normal distribution, but only for one of the coefficients. Okay? What is the probability that it has 2 x-intercepts? Well, to have 2 x-intercepts, again, we need b squared minus 4ac, both a and c are 1, right? To be bigger than 0. So we need what? 4c squared to be bigger than 4. So we need c squared to be bigger than 1, which means c have to be bigger than 1, or, don't miss the negative case, c is less than minus 1. But this is what? This is a normal distribution, right? So we can find this probability using normal distribution. What do I want? Less than minus 1. So 0.15865. The other side is the same, right? So we just times 2. 7. Then 7 mark. So the last part is actually the hardest part of the question. Continuous random variable x1, x2 represent x-intercept of the graph, with x1. I think this simply comes from doing the quadratic formula with the quadratic, so I don't think it means much. what is the probability that both of x1 and x2 are bigger than 0.5? Oh. That seems tricky. So this is bigger than 0.5. And the other one is also bigger than 0.5. I guess we'll do some algebra, see what would happen first. So we might add the z to the other side. So 0.5 plus z. Like that. Now the first thing is, if you think about it, this condition is actually useless because x2 is obviously the bigger root, right? Because of plus, right? You add something, you're bigger. So if x1, which is the small root, is already bigger than 0.5, then the bigger one is definitely bigger than 0.5. Yeah, so this condition is useless. We only need to take care of this. I kind of want to square both sides at this stage, but I'm trying to be careful because because squaring both sides is always tricky, especially in an inequality or when square roots are there, which we have both right now. I guess the safest way is actually to graph this. Yeah, let's not even rearrange it, just graph the left hand side. And that's the safest way. X minus square root x squared minus 1 and 0.5. So where's the intersection? It's negative 1.25. So the root thing, I think it's a red graph, but the root thing to be bigger than 0.5, the z value need to be bigger than 1.25. But we still have to be careful with this, right? If z is too big, for example, if z is only negative 0.5, then z squared minus 1 will be negative. Alright. So I think we need this as well. Z also need to be less than minus 1. Okay? So that's when, so this is the condition for x1 to be greater than 0.5. And if x1 is greater than 0.5, x2 is also automatically greater than 0.5. So we want the probability of that. Except there's one last trick. The trick is that this is a given. Turn out this is a conditional probability. So you want the probability of this given that f indeed have true x-intercepts. When does that happen? That happens when this happens. So that's related to part G. That's when the graph has two x-intercepts. So given that z is bigger than 1 or z is less than minus 1, so conditional probability. So it's A and B over the probability of B. The probability of B is what we found. Now for the top, what do we need now? We need z to be in between negative 1.25 and negative 1. and z is either bigger than 1 or less than minus 1. Alright, and this is the n. So we really want the overlapping part of A and B. So what kind of values of z would satisfy both A and B? I think it's just negative 1.25 to negative 1. Right, because once z is between negative 1.25 and negative 1, you have already satisfied this condition. And this is OR, so you only need to satisfy one of them. And you can only satisfy one of them. You're either bigger than 1 or less than minus 1. You can't be both. So we want that probability. Again, that's a normal. So what's that? Negative 1.25 minus 1. So is that. And that. .167. Okay. So this last part, this last 7 mark, is proved to be not stupid at all. It's quite tricky, but yeah. So I don't think doing any algebra with this is a good idea. You might mess up a lot of stuff. So the best way is actually just to graph it to get negative 1.25, but you need to also remember that z will have to be less than minus 1, because otherwise you'll root some negative stuff, which can't happen. And then you need to notice the fact that this is a conditional probability in order to get full mark. Yeah, but the previous part of the question is probably quite time consuming. If you didn't figure out, they just want you to do trial and error. So that makes it even harder, right? Probably don't have a lot of time left.